Now we shall talk about some special triangles, right? We have already talked about equilateral triangles. We have already talked about right angle triangles. We have already talked about Pythagorean triplets. Now we'll talk about some angle specific triangles. The first one of them is 30, 60, 90 degree triangle. It is actually a right angle triangle, a specific right angle triangle in which the angles are 30 degree, 60 degree and 90 degree. Now it is important to understand the side opposite 30 if I take it as A, side opposite 60 if I take it as small b, and side opposite C if I take it as small c. The ratio of sides A is to B is to C is straight away equal to 1 is to root 3 is to 2, right? This is very, very important to understand. So if I take this side A as x, then this side B should be x root 3. The side C should be 2x. So please keep that order in mind. Okay, so for example, if I give you, let's say this is 30, this is 60 and 90 degree, right? And if a side opposite 60 is 12 centimeter, then side opposite 30 will be 12 by root 3. Please take the note of the order in the ratio on your own. And this will be 24 by root 3. So whatever is the side opposite 30, twice of that will be the hypotenuse and root 3 times will be the other side, right? So this is one angle specific triangle, that is 30, 60, 90 degree. Side opposite 30 degree will be represented as 1 in the ratio. Side opposite 60 degree will be represented as root 3 and opposite 90 degree as 2. This is one direct relation which will be extremely useful in your cases, right? So this is one angle specific triangle. The other one is a little more obvious. It is actually 45, 45, 90 degree. The triangle in which one angle is 45 degree, one angle is 45 degree, and this is 90 degree. Now this has nothing much to do, because if 45, 45 angles are there, then the two sides are equal. So if I take one side as 1, the other side will also be 1, and because it is 90 degree, applying Pythagoras theorem, we'll get the third side as root 2. So this is a little simpler to understand. It is 1 is to 1 is to root 2. Okay. Opposite 45 degree, 1. Opposite 45 degree, 1. And opposite 90 degree, root 2. Okay. So if I give you it is also, you can see that it is half of a square. So if I give you a situation as 45, 45, 90, right, and one side has 10 centimeter, then clearly the other side has to be 10 and the hypotenuse has to be 10 root 2, right? Or otherwise, if I give you the hypotenuse of a triangle in which angles are 45, 45, 90 as, let's say, 20 centimeter, then other two sides will be clearly 20 by root 2 and 20 by root 2. So please make sure that you understand this. Okay. And there is one more specific triangle. I'll use this space, okay, and that is a very interesting situation. It's an isosceles triangle. It is not a right angle triangle or equilateral. It is a specific situation in which two angles are 30 degree and 30 degree, okay, and one angle is 120 degree. Now clearly the sides which are 30, 30, sides opposite to them will be equal. So if I take them as 1 and 1, then the third side is root 3. So this is what you need to remember. So in this triangle, side opposite 30 degree, side opposite 30 degree will be equal, and side opposite 120 degree will be large, and the ratio of the sides will be 1 is to root 3. Right? So if I give a situation like this, this is 30, this is 30, and if this side is 30 centimeter, then the other two sides will be what? It will be clearly 30 by root 3. Please be careful of the order. 30 by root 3 centimeter. Right? So largest side is represented by root 3. Other two as 1, 1. I hope you can understand the importance of order in a ratio. Okay? If I give you a situation like this, and if I say that this is 30, this is 120, and this side is 10 centimeter, what does that mean? Clearly this is also 10 centimeter, and this will be 10 root 3 centimeter. I hope you are able to understand the changes in the orientations. Okay, so these are some specific triangles that should be remembered directly without any confusion. It's important to understand the ratio of sides, okay, and it is important to understand the correspondence of angle and opposite side. Okay, I hope that makes sense. Now, where does this come from? This comes from a couple of formulae of trigonometry. I'll just take them up. There are multiple ways in which the specific situation that we just discussed just now can be explained. This is one way, that is sine rule and cosine rule. The sine rule says very clearly the ratio of sides A is to B is to C is equal to ratio of sine of the opposite angles. So A, corresponding to A, we will have sine A, corresponding to B, we will have sine B, and corresponding to C, we will have sine C, right? And this also gives us, or rather this comes from A upon sine A is equal to B upon sine B is equal to C upon sine C, right? This is where it comes from. And interestingly, all of these ratios are also equal to 2R. Okay, this capital R is the circumradius, but we don't need to worry about it. Understand this part, or rather this part. Ratio of sides is equal to ratio of sine of opposite angles. Okay, this is called sine rule. In fact, focus on this only. Fine, or focus on this part only, right? Now, what is cosine rule? Cosine rule is also the relation between the sides and the angles, but this uses cos. How? Let's see. It says cos of A can be calculated if you know the sides like this. Angle A is made by side B and C. So B square plus C square minus the opposite side A square divided by 2BC, right? So this is the situation. Similarly, you can express cos B, and that is C square plus A square minus B square divided by 2CA, and cos C is equal to A square plus B square minus C square by, it is 2AC, and this is 2AB, right? But you also need to understand that these are the formula, these are the good formula, but there cannot be a question in the exam which cannot be solved without using them. I repeat, these are good formulae, essential formulae. You don't need to go further in them. You don't need to be, have a great knowledge in trigonometry. No, that's not the case at all, right? If you are good about this, if you are aware about this, fine. Otherwise, go ahead. Doesn't matter much. Okay, there will be no question asked which requires this only. It won't happen. There will always be some alternate method. Okay, but yeah, having said that, please make sure that you understand the usage of this ratio, right? There should be no confusion about it, or this. I'll write it again. A upon sine A is equal to B upon sine B is equal to C upon sine C. Right? So even if I'm using trigonometric formula, it doesn't mean that the trigonometry is an essential requirement for your exams. But you must know the values like sine 30 degree, sine 60 degree, right? Sine 45 degree. At least these values you should be definitely aware about. Whether you have, if you have passed your 10th, you must know these values. Okay, and while doing them, also include cos 30 degree, cos 60 degree, cos 45 degree. Okay, also include sine 120 degree and cos 120 degree. This is good enough. Sine 120 degree is root 3, cos 120 degree is minus 1 by 2, cos 30 degree is root 3 by 2. Cos 60 degree is 1 by 2, cos 45 degree is 1 by root 2, sine 30 degree is 1 by 2, sine 60 degree is root 3 by 2, sine 45 degree is 1 by root 2. Just confirm them and remember or memorize these values. Just memorize these values. That's it. If you are applying any more of your brain or mind in this, you're wasting your time.